If the power circuit board of a higher mini-split air conditioner is working perfectly, as we explained in our previous video, but the compressor still isn't functioning, then the next circuit board responsible for driving the compressor comes into play. This is the IPM circuit board, also known as the IPM module PCB. We'll explain this circuit to you in complete detail. Before getting into the IPM circuit, let me first explain its wiring. The white and black wires carry the neutral and phase, respectively. These neutral and phase wires go into the rectification circuit, where the voltages are converted from AC to DC. After being converted to DC, a ceramic capacitor is placed in the circuit to filter out spikes in the electricity. After this, the wire goes to the reactor, where the DC spikes are controlled, or at least minimized. Following this, another wire returns to the IPM circuit. At this point, the positive and negative wires boost the voltages. Here, 320 volts DC should be present in standby mode. When the circuit is in working condition, there should be 380 volts DC. This combination of wires is designed to control the voltages within the IPM circuit. Friends, let's now talk about where the low voltages for this IPM module PCB come from. If you look here, this connector, which comes from the power circuit board, supplies 15 volts and 5 volts to the IPM circuit board. Besides this, there's another connector here. Look at this black connector. This wire, connected to the black connector, facilitates communication between the IPM circuit and the power circuit board. In other words, it allows these two boards to talk with each other. These two connectors function in this way. Now, friends, I'll explain why the outdoor compressor might not be starting and the possible reasons behind it. I always recommend that you first check the high side and then check the low side. But first, I'll explain the high side circuit to you. Then I'll tell you where the voltages come from and where they are used. In the high side circuit, as I've already explained about the rectification process, we should get 320 DC volts at the positive and negative terminals in standby mode. When the circuit is working, the voltage should go up to a maximum of 380 volts. If these voltages are correct, that's good. Next, if you're not getting the correct voltages here, you need to consider what could be the cause. The first reason could be that the voltages are fine up to this point, but then they disappear. The most likely reason for this could be the rectifier. It could be damaged for some reason. If the rectifier is faulty, the voltages won't pass through. But if the rectifier is passing the correct voltages and you're getting 320 volts on the capacitor pin after rectification, but these voltages aren't reaching the IPM, then what could be the reason? The reason could be the two power resistors installed here. These are overcurrent resistors, designed to control excessive current. If the current becomes too high, these resistors will open or burn out, protecting the rest of the system. These resistors are rated at 5 watts and 10 milliamps per joule. Both resistors have the same values. If the voltages are correct at this point, but the system still isn't running, the reason could be that the IPM itself is faulty. I've shown in many of my previous videos how to test the IPM. If the IPM is fine, but still isn't properly driving the compressor, then the IGBT could also be defective. You should remove it from the circuit board and test it separately. This way, there's a good chance you'll be able to fix the circuit. Once you've checked the IPM and IGBT, and all the high side components are functioning correctly without any issues, but the outdoor unit still isn't working properly, then the problem could be related to the low section as well. So, let me explain where these voltages come from, how much they are, and how many volts are used at each point. I'll also tell you which components in this section could be damaged. Now, let me explain where the 5 and 15 volts are present on the pins. The right side pin has 15 volts. The center pin is the ground, and the left side pin has 5 volts. If you're getting these voltages at these points, but the unit still isn't working, I'll tell you what else needs to be checked. First, you should check resistor number 212. If this resistor is open, the system won't receive the 5 volts it needs, and the circuit board won't function. Even if you have 5 volts here, if this IC, which is an amplifier IC with the number 2772Q1, becomes open or short-circuited, the system will still not work, and the unit will display an error. Additionally, if resistors number 210, 209, or 207 are short-circuited, the system will also not function. There's another amplifier IC installed here, IC number 4. If this IC becomes open or short-circuited, the system will again fail to operate. One more important component to check is resistor number 205. If this resistor is open or short-circuited, replace it. This might fix your system. Resistor number 008 should also have 5 volts present. If this resistor is open or short-circuited, the system won't receive the necessary 5 volts, and you'll get an error. There's another critical component, IC number 5. If this IC isn't functioning properly, the system will not turn on. This IC is labeled LM293, and it's a dual comparator. Its job is to sample the incoming voltages and relay this information to the microcontroller. If this IC fails, the microcontroller will stop the system, thinking that the voltages are incorrect. The IC has an 8-pin setup, and connected to it are resistors 217 and 219, which should have 5 volts. If these resistors become open or short-circuited for any reason, the system won't function. Next, there's resistor 032, which should also have 5 volts. If this resistor fails for any reason, the system will not operate. So make sure to check all these voltages here. Additionally, friends, there are other voltages that should be present on this circuit board, which I'll also explain. Resistor number 0117 and resistor number 005 should both have 5 volts. If these 5 volts are not present, the EEPROM will not function, and the system will hang, rendering it unable to perform any functions. Furthermore, diode 205 and resistor number 229 should have 5 volts between them. If these 5 volts are not present, you'll need to check this resistor. If either of these diodes becomes damaged, the voltages won't be there. Similarly, if this resistor gets damaged, the required voltages will also not be available. Additionally, I'll let you know that the microcontroller should have power voltages between pins 4 and 6 and between pins 22 and 24. If these voltages are missing, it indicates a problem in this area. This circuit has a TVS, transient voltage suppression, diode installed to control high voltages. This creates a high protection system here. To reduce voltage spikes, there are 3 capacitors installed, which help to minimize these high voltage spikes. Moreover, the 5 volts should be present on the second pin of the IGBT driver. If you don't find 5 volts at this point, it means the 5 volts are not reaching there. In such a case, you should check the circuit, and once you ensure that the 5 volts are present, the IGBT driver will turn on. Let's talk about where the 15 volts should be available and what issues could arise if they're not present. The 15 volts should first come to the IGBT driver on pin number 8. If 15 volts are present here, the IGBT driver will continue to function properly. Now, I'll tell you where else these 15 volts should be. There is a capacitor here, and its pins should have 15 volts. If the 15 volts are not present at this capacitor, it could be shorted. Additionally, there's a Zener diode located here that could be open, which would also prevent the 15 volts from reaching this part of the circuit. Next, there are diodes that should have 15 volts on their positive side. If you don't see 15 volts here, the first step is to check the resistors associated with these diodes. If any of these resistors are damaged, they can interrupt the 15 volts. If the 15 volts reach the diodes, the capacitors could be short-circuited, as well as the small capacitors used for filtering. If any of these capacitors are shorted, it can still cause problems. The component that actually turns on the compressor is the IGBT. When the IGBT turns on, the compressor starts. To turn on the IGBT, there's an IGBT driver, which is labeled as 3150. When this IC is functioning and turns on, it activates the IGBT. However, to turn on the IGBT driver, an NPN transistor is used. This is how they activate each other, leading to the compressor turning on. Now, let me explain what faults could occur here. Resistor number 011 might be faulty. If this resistor becomes open or short-circuited, the power transistor won't turn on, and other components won't function either. Similarly, resistor number 224 could also be a problem. If it becomes open or short-circuited, the system won't operate properly. Moreover, if resistor number 223 becomes short-circuited or open, it can cause issues in this circuit. This is because this resistor directly controls the transistor, and it is also under the control of the microcontroller. So if any problem arises in this section and the transistor gets damaged, but the resistor is still intact, there's a chance that the microcontroller will remain functional. However, if the resistor becomes short-circuited, then there is a chance that the microcontroller could also get damaged. In that case, the chances of successfully repairing the circuit will be significantly reduced. If you still want to take a chance, you can try replacing the resistor and check if the unit turns on and the circuit starts working again. Here's another scenario where the communication system between the IPM PCB and the power PCB is not functioning properly, leading to an F3 error on the display. This issue could be due to several factors. For instance, if resistor 0112 is damaged, It could cause problems because this is where the 5 volts are supplied, and any damage here could disrupt the circuit. Similarly, if resistor 0119 is damaged, it could prevent the necessary 5 volts from being delivered, leading to further issues. Another potential culprit is the TR2, a PNP transistor, which, if damaged, could also create problems in the circuit. Additionally, if one or both of the optocouplers are damaged, the communication between the boards could be lost, resulting in the system displaying an error. These are some key repair tips for troubleshooting this circuit and ensuring the correct voltages are being supplied. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.